In this video, we will dive deeper into operators. We will discover some strange quirks in the way they behave. In most cases, the operators that you used previously will behave as expected. However, in some cases they may display some behaviors that seem a little unexpected. It may be necessary to pause the video on some of the following slides and study the examples. Let's start with a well-known source of bugs: divide by zero. Dividing a number by zero is often a bug. Different programming languages deal with it in different ways. In Python, an error will be thrown. In JavaScript, no error is thrown, but it results in the value infinity. Mobius follows the JavaScript approach. Next, let's look at operators acting on strings. A sort function can be used to sort a list of values. If the values are numeric, then there is no issue. But if the values are strings, then the sort function will need some kind of rule of sorting the strings. For strings, the sort function will use the greater than operator to compare values. In the code, a number of examples are shown. Strings are sorted based on the individual characters in the string. Characters at the end of the alphanumeric sequence are greater than characters at the beginning of the sequence. Alphabetic characters are always greater than numeric characters, and lowercase characters are always greater than uppercase characters. This last one is a bit counterintuitive. The addition operator with numbers and strings. If both operands are numbers, then the behavior is as expected. The result will be a number. If both operands are strings, then the strings get concatenated. The result will be a string. If only one operand is a string, then the other operand will be converted to a string. And the two strings then get concatenated. Note that numeric strings are not converted to numbers. The other arithmetic operator with numbers and strings. If both operands are numbers, then the behavior is as expected. The result will be a number. If either operand is a string, then the result will be not a number. This is a special value to representing something that is not a valid number. But now be careful. There is an exception. If both strings are numeric strings, then they will both be converted to numbers. So the other arithmetic operators behave differently from addition. Another common requirement when coding is to convert non-Boolean values to Booleans. This is commonly used when writing conditional statements, which we will look at later. For numbers, 0 becomes false. Everything becomes true. For strings, the empty string becomes false. Everything becomes true. For lists, the empty list becomes false. Everything becomes true. Lastly, let's look at how the logical operators behave when both operands are either numbers or strings. For the AND operator, we usually say that it evaluates to true when both operands are true. But this is actually a special case of a more general rule. The general rule does not require the operands to be Boolean values. And it does not require the result to be a Boolean either. Given to operands, alpha and beta, the rule states that if alpha evaluates to true, return beta, otherwise return alpha. Or in a short form that is easier to remember, if A then B, otherwise A. For the OR operator, we usually say that it evaluates to true when either operand is true. But again, the general rule requires neither the operands nor the return value to be Boolean values. Given to operands, alpha and beta, the rule states that if alpha evaluates to true, return alpha, otherwise return beta. Or in a short form that is easier to remember, if A then A, otherwise B.